Okay, this lesson is for 9.3 Pythagorean Theorem. Start off talking about exactly what the Pythagorean Theorem is. In words, we would say that for any right triangle, and we know that this triangle here is right because it has a 90-degree angle there. So for any right triangle, the sum of the squares of the lengths of the legs, so you see how side A here is a leg, side B is a leg. The sum of the squares of the lengths of the legs equals the square of the length of the hypotenuse. So the hypotenuse is always the longest side of a right triangle opposite the 90-degree angle. The Pythagorean theorem says in algebra that a squared plus b squared equals c squared. And so now with respect to the legs, it doesn't matter which is labeled A or B, but the hypotenuse must always be labeled C. Okay? Let's look at an example. For this first example, we're going to find the length of the hypotenuse. I know that that's what we're going to do because that's the side that's not given to us. Always start off by writing the actual formula for the Pythagorean theorem. So, a squared plus b squared equals c squared. And then we'll make our substitution. So under here we'll put in 212 squared plus 478 squared equals c squared. We don't know what that is yet, so we leave it at c. And now we go ahead and simplify, evaluate the powers, and 212 squared is 44,944. 44,944, okay? We add that to 478 squared, which is 228,484. So 8,484. And that equals c squared. Now we add them together, we'll get 278,000, oops, again, eyes are playing tricks on me, 273,428, that is c squared. Sorry about that. Okay, and so we're trying to figure out what c is. We know what c squared is, but we don't know what c is. In order to figure out c, we have to do the inverse operation. The opposite of something being squared is to find the square root. So we need to take the square root of both sides. That's how we're going to get c. And we're going to get a decimal, but we're going to round to the nearest whole number. And so we get 523, approximately 523. And because it's an approximation, I'm going to make this symbol right here, two little squigglies. This is approximately c. It's really important that every time you round, you use the approximate symbol. It doesn't equal c. Equal means it's the exact value. Anytime you round, it is an approximation. But the answer is that it's 520, approximately 523. Or you could say about, around, close to. Those all mean that you rounded. Okay, let's look at another example. Here we're trying to find the length of a leg, and that would be leg A. We always start off writing the Pythagorean theorem. So a squared plus b squared equals c squared. We make our substitutions, and so I'll have a squared plus 10 squared equals 12 squared. And then we will evaluate the powers. We can't do anything with a squared, so we'll leave it. 10 squared is 100, and 12 squared is 144. Okay, we have to solve for a, meaning we have to get it by itself on one side of the equation. So we'll need to subtract 100 from both sides. Since it's being added, we need to subtract. Okay, and then I'll be left with a squared, and I'm moving it over because this disappears. A squared equals 144 minus 100 is 44. So a squared is 44, but we need to know what a is, and in order to do that we have to take the square root of both sides. And when we do, we are 44 is not a perfect square, so we will get a decimal approximation, A is approximately, and this time I'm going to round to the nearest hundredth. That means 2 places behind the decimal, 6.63. And I'm sorry, I forgot about the units. Always have your units. Okay. So here's the last thing for us to talk about. Okay. The converse of the Pythagorean theorem. So we know that if we have a right triangle, that means that a squared plus b squared will equal c squared. But what if you're given 3 numbers and you have to determine whether or not they would form the sides of a right triangle? So if a triangle is a right triangle, then they will always work in this formula. Then the sides, the length of the sides, a squared plus b squared equals c squared. The converse of the Pythagorean theorem says that first we need to determine if the numbers can work in this formula in order to figure out whether or not they represent the sides of a right triangle. So if you're given 3 sides and you discover that c squared is actually less than a squared plus b squared, it's not a right triangle. In fact, it would be an acute triangle. Notice how small the angle is because a and b are larger. The combination of a squared and b squared would be larger than c. And then over here, this is an example of where c squared would be greater than the sum of a squared plus b squared. It must be an obtuse triangle. Look at how much longer c is. That means that this angle has to be more than 90, making it obtuse. So what we're going to do for our last example is to identify whether or not we have been given the sides to a right triangle. They must work in the Pythagorean theorem. Okay, so starting with problem A, we have our 3 sides. We start off by writing the formula for the Pythagorean theorem. A squared plus b squared equals c squared. And then we make our substitutions. And now, I'm telling you which is a, b, and c, but even if I didn't, the largest number should always be c. Alright, so we'll say 3 squared, making our substitutions, plus 5 squared. The question is, will it equal 7 squared? And so because we don't know, I'm going to put that question mark in there. Alright, so let's go ahead and evaluate the powers. So we'll have 9 plus 25, and the question is, will it equal 49? And when we add 9 and 25, we get 34. And 34, I can tell you, it does not equal 49. What does that mean? That this is not a right triangle. And I'm going to abbreviate here. Not a right triangle. That's the answer. Let's go and try it over here. So we start off with the Pythagorean theorem. A squared plus b squared equals c squared. We need to see if it will work. So I make my substitutions. 15 squared plus 8 squared. The question is, will it equal 17 squared? And when I evaluate the powers, we get 225 for 15 squared plus 64. The question is, will that give us 289? I just happen to have those memorized. Alright, so then when we add 225 to 64, we'll get 289. And since 289 does indeed equal 289, that means that these do represent the sides of a right triangle. Okay, and anytime we have 3 sides, 3 numbers that will actually work in the Pythagorean theorem, we have identified a triple. And triples are sets of numbers that will always work in the Pythagorean theorem along with their multiples. So here's an example of a triple, 8, 15, and 17. That also means that any multiples of these numbers would also work in the Pythagorean theorem, meaning let's say if A was 30 and B was 16 and C was 34. Notice what I did? I multiplied them all by 2. 15 times 2 is 30. 8 times 2 is 16. 17 times 2 is 34. These are already going to work in the Pythagorean theorem. I already know it. Because in their most reduced form, 8, 15, and 17, we see that it does indeed work. That means it's a Pythagorean triple. And that's all that we have for today. Have a good evening.